Hello everybody, today we are going to be taking a look at the activity scheduling problem. So, let's go through this problem and see what it asks for. You are given n activities with their start and finish times. Your task is to select the maximum number of non-overlapping activities that can be performed by a single person. Two activities are compatible if the start time of one is greater than or equal to the finish time of the other. So, for example, here we have an input of a bunch of different activities. So, we want to figure out a way to fit as many activities in possible without like having this schedule conflicting. So, for example, we're going to assume that we're going to say 1 p.m. to 2 p.m. for example, but obviously there's a 0 here. 0 would be indicative of midnight. We could also say this starts at 1 hour past a specific time and 0 being that specific time. But essentially, we have one that goes from 1 to 2, 3 to 4, 0 to 6, 5 to 7, 8 to 9, and then 5 to 9. So, we obviously could not fit, for example, 5 to 9 within 8 to 9 because both of these activities would overlap each other because both of them end at 9 but start at different times. So these two cannot be in the same list together. But we also want to fit 1 and 2 and 5 and 9 together, right? Because, or 1 and 2 and 8 and 9, because those two are definitely going to be separate. So the output we get is, we get 1 and 2, 3 and 4, 5 and 7, and 8 and 9. And this way we fit 4 activities. We can't fit all of them because there will be overlapping activities. Like, for example, we can't fit 0 and 6 into here because it would get into the way of 3 and 4. And so on and so forth. So, it seems like a pretty simple problem, but how do we go about solving this exactly? How do we determine which activities are overlapping and which ones are not? The way that I would suggest doing this, and the approach we're going to be taking here, is we're going to be taking a greedy approach, where we always want to choose an activity that finishes earliest while we're skipping the overlapping activities. So, sorry about that, guys. We want to be sorting the activities based off of what activity finishes earliest, right? So if an activity finishes early, that means we have more room for time to fit more activities into the schedule. So that's why we want to take into consideration the finishing time of the particular activity. So what we're going to be doing is we are going to be starting by sorting the list by the finish time. And then if we see the finish time is um, after the next starting time in the next list, then we can skip it because we know it's overlapping. So that's our overall general strategy, and we'll go more into what that looks like. So first, let's create our function def activity underscore selection activities. So, how are we going to do this? We want to sort this list by the finishing time. So how are we going to sort this entire array? Well, there are a couple ways of doing this. One, we could obviously split this up, make a new list of just the finishing times and sort that list. But there is a way to do it all in one line. What we can do is we'll say activities.sort, and to do this, we would make it by the key. We're going to be using a key, so we're going to say key is equal to lambda x. And what we are going to be doing is we are setting x of 1. And what this does is this will automatically sort by x of 1, which is the second position in each of these tuples, because index of 1 means the second position in our tuple, and it will sort every single tuple in our list by the lambda key, the key of lambda x, and this will sort by the finishing times. So we already got it there. We could also like quickly test this out by like showcasing that we already got it. Print activities. We'll just do this just for the test to demonstrate that this actually does sort our list. Although I'm sure you guys believe me. Activities is equal to, let's copy paste what we got here. If we just run activities selection of activities and then print activities, we will see that they are actually already sorted by the finishing time. We inputted 1, 2, 3, 4, 0, 6, 5, 7, 8, 9, 5, 9, 9. But, okay, well, I guess in this case, the list was already sorted. But, like, for example, if 1, 2 was in the end, and we run this code, we can see that 1, 2 is now at the start. So this automatically sorts it by the finishing time of the activities. Now that we have that sorted, now all we need to do is make our condition so that, well, first of all, we want to obviously create our output array, output list of selected. And we're going to be going over, we have to continuously use a greedy approach to select the activity based off of the finishing time. So we'll start with a last finish of the least possible time, obviously, because like -1, for example, because -1 cannot be in our input array. We're assuming that there's a non-negative value, and there's no negative values in our activity list, so we'll choose one of -1. Now all we need to do is loop through the list for start, finish in activities. Start, finish are obviously the first and second index in the tuple that we just created. If the activity doesn't overlap. So how we see that? If start is greater than or equal to last finish, then we know that the last finish value is overlapping with the next activity's starting point. So we say selected. If the start is greater than the last finish, we know that they are not overlapping. Sorry for my thing there. I said they are, if start is greater than the last finishing time, they are non-overlapping, so we can just append it to the list, and we can append it in the form of the start finish tuple. Start, finish. And obviously we're going to now set the last finish to finish the new activity that we just added. And there it is. That's the logic, simple as it is. And at the end we can return the selected list where the selected activities that are chosen. So now we're not printing just activities here. We are going to be printing out activity selection of activities to test out to see if we got the logic right. We can run our code and we can see here that it selected specifically 1, 2, 3, 4, 5, 7, and 8, 9, just as in our output example. It found all the possible activities that we could fit together, the most possible activities that we could fit together without any of the activities overlapping each other. And there we go. That's how we solved it using a greedy approach. As always, the time complexity of this operation was we were sorting the list, right? We had to sort the list based off of the second index, regardless of not of whether it was just whether you're sorting an entire tuple based off of an index, or if you're just sorting off a list with all the tuples in it. Sorting is always a big O n log n operation when it comes to these types of integers. In the most efficient way, sorting is always going to be n log n. So the entire we had to do one additional loop here to loop through the entire thing, but still overall the time complexity is going to be big O of n log n, and there is no additional space complexity, so you could say the space complexity is big O of 1, because all you're doing is um, outputting a similar size list to what was initially inputted, so there's no additional space complexity other than what you output. And there it is. That was the time complexity, and hopefully you guys understood the greedy algorithm approach to solve this problem. And I'll see you guys next time. Bye bye.